Good day, class. Welcome, students. Today we meet again. I think you've taken your time. I hope you have taken your time and go through my previous video. I remain Mr. Jude Anadozie. Today we're looking at a new topic with particle duality. With particle duality. You all know of matter. And matter, you are told, is anything that has mass and occupy what? Space. But matter appears to have a dual nature because in one instant it behaves like a wave, while in another it behaves like what? A stream of what? Particles. So according to de Broglie, he derived the wavelength of a particle wave. But I am not that interested in his equation. I'm interested in how he got that equation. But matter have dual nature. Behaves like sometimes behaves like a wave. In other case, it behaves like a stream of particles. And when we did radioactivity, we agree that energy equals what? Mass times what? Speed of light square. We agreed on that. And under energy quantization, we agree that energy also equals to Planck constant times what? Times frequency. Now, we trying to marry these two together. Marrying these two equations together, we now have what? Mass times square of speed of light equals to what? Planck constant times what? Frequency. Recall that velocity equals to lambda times frequency. So frequency equals to lambda over velocity over wavelength. And since we are discussing about speed of light, we are not really talking about speed of light. Okay, we use this. Yes, we just use this. And here we're not talking about light, we're talking about matter, right? So let's change this velocity to v. Let's change it to v. So we have mv square equals to Planck constant. F is this, v over what? Lambda. So when you cross multiply here, you have what? Mass v square lambda equals to what? Planck constant times what? V. Dividing both sides by v cancel this cancel this. So Planck constant equals what? Mass times velocity times what? Lambda. Mass times what? Velocity times lambda. So still on that, let's proceed. Still on that, let's proceed. When you divide both sides by mass times velocity, this eliminates this. We now have Planck constant equals to what? Lambda, which is wavelength, equals what? Mass times what? Velocity. Recall that mass times velocity is same as what? Momentum. Same as what? Momentum, which is presented as what? P. So this is what we call the Broglie's equation. But in today's class, I will go ahead and break these equations down to different forms so that in any way question should come, you will know what to do and how to tackle the question. So I'll be beginning from that point. So see at that point, let's clean the board. Where is this thing? See at this point. So let's proceed from there. So we've agreed that lambda equals what? Planck constant times what? Momentum, which is mass times what? Velocity, which is mass times what? Velocity. So, and you recall in energy quantization, an electron of mass with acceleration voltage v has kinetic energy 1 over 2 mv squared, right? And momentum equals to what? M what? V. Hope you get it. So looking at that in our previous, so let's just underline this and keep this aside. Let's just keep that aside. So you already before now that electron volt, which is energy, under energy quantization, if you don't understand this, go back to my energy quantization. Mass of electron times what? Speed of electron. So we agreed and we proved this before. So now when you cross multiply this, you have 2 electron volts equals to mass of electron times square of what? Velocity. This is okay. Let me use small v here and big V for voltage, small v for velocity. Yes. So by the time you divide both side by small v, you now, so this small v cancel this square. You now have mass times velocity is equals to what? 2 electron voltage over what? Velocity. Velocity. I hope you are with me. I hope you are with me. So, say at this point, and we've agreed, we've agreed that lambda Planck constant is momentum, right? And this also is momentum. So I can write this as what? Planck constant over what? 2 electron volt over what? Velocity. 2 electron volt. So that means Planck constant equals to what? Lambda, sorry, equals to Planck constant times velocity over what? 2 electron what? Volts. Take note of this formula. Take note of this formula. Every derivation you see me prove, please try on your own to what? Derive it. So that you become what? Become part of you, and you won't what? Easily what? Forget. So I've proved this. I've also proved that. And question also can come in another form. In what? Another form. In which form again should we be expecting question to come in? Let's look at a situation. Let's look at a situation. Let's erase this, okay? Erasing this, I prove that this is same as what? Planck constant times velocity equals to 2 electron volts. Still recall that electron volts equals to 1 over 2 mass of electron velocity what? Velocity square. At this point, let's try to make velocity the subject of the formula. So here, when you cross multiply, you have what? 2 electron volt equals to mass of electron velocity what? Square. Dividing both sides by what? Mass of electron. Mass of the electron. This eliminate this. So we have V square equals to what? 2 electron volt over what? Mass of what? Electron. So getting the square root of both sides, the square root of both sides will now give you what? V now equals what? Square root of what? 2 electron volts over what? Mass times what? Mass of electron. 2 electron volt over what? Mass of what? Electron. And you recall that momentum is what? Momentum is what? Mass of what? Electron what? Times velocity. Mass of electron times what? Velocity. That is momentum. And now we agree that this is velocity also equals this. So I can substitute this for this. So give us what? Momentum equals to what? Mass of electron square root of what? 2 electron volt over what? M what? E. So that is where we are now. So let's proceed from there. If we move down, so what do we expect to have? What are we expecting? Taking this mass into this equation, so giving us momentum, which is going to be what? Square root of 2 electron volt me square over me. Square root of me square will give this m. So this me cancel this. So we have what? Momentum equals to what? Square root of what? 2 electron volt multiplied by what? Mass of what? The electron. 2 electron volts multiplied by what? Mass of the what? Electron. So at that point, coming to this, recall that this man is taken as lambda equals to Planck constant over momentum. Momentum is what? Mass and velocity. So I can say this is equals to what? Planck constant over what? Square root of what? 2 electron volt mass of what? Electron. 2 electron volt mass of the electron. Where all symbols and constants maintain their what? Usual meanings and what? And values. Maintain their what? Usual meanings and what? Values. So I would love you, I know you can do it, to go through this work. This is derivation. I started from here. I derived these two. Then this is what? Third one. So I have to know it, go through it. So from here, in our next class, we'll look at some questions on this. But we're still in what? Wave particle what? Paradox. The wave particle duality. From there, we now move to what? Each bulk of uncertainty. We move to what? Uncertainty principle. There's nothing in it, it's just physics. Just physics. The Broca's equation is this. How do we get this? How do we get this? Let me recap again. I got this from what? Energy equals to what? Mc square. Energy equals to what? Hf. Changing this to what? Velocity. Are you getting me? Then we got lambda from here. This is v over lambda. Making lambda the subject of the formula gave us this. Because v eliminated was this square. So making lambda equals to what? Planck constant to us mv. And what mv is taken as what? Momentum. Taken as momentum. So from this point, we now moved ahead. Equating 1 over 2 mv square towards electron what? Volts. Are you getting me? Try to convert mv from here. So try to make a bigger mv. So it's mv square equals to 2 what? Equals to 2 ev. Removing v from here, that divided both by velocity. This is both, not velocity. This one is velocity. So now have mv equals to 2 ev over small v. Do you get it now? Now, taking this guy now to replace this. That's how we got this. Then from this point again, making v the subject of the formula. Making v the subject of the formula and equating to what? Momentum. Making it solve the formula gave us this. Okay, this is it here, yes. E is sorry formula, making V the solid of the formula here, velocity not voltage. We're able to arrive at this. Then fixed into momentum give us this. Then from here, from there, we now move down. This is ME. Square root of what will give us ME? Square root of ME square will give us ME. So as I'm taking it inside the square root sign, give us this ME remains ME. So now momentum equals to this. And I call that this is momentum. Momentum. So this substituting this sign ended up giving us this. So I would love you to go do this, prove it yourself. It's what you can do. Believe in yourself, you can do it. And together we grow. Together we grow. Take notes. If you haven't subscribed, please do subscribe. More is coming on this channel. More and more is coming on this channel. More and more is coming on this channel. Thank you. Thank you. Thank you.